When you've got multiple coroutines all running in parallel, it's easy to lose track of what's happening at any given moment. And for a long time, the debugging tools for coroutines didn't really help much. The usual stack traces aren't very helpful for coroutines because coroutines can run a little bit of their code on one thread and then a little bit on another thread. And there's just a lot of internal machinery that kind of muddles up that stack trace. The good news is that IntelliJ IDEA and Android Studio include some debugging tools that now make it easier than ever to know the state of your different coroutines. So today we're going to take a quick look at some of those tools. And here I've got some example code for a kitchen where we're grilling a steak, making a salad, and cooking some eggs. And I included all the way down here this prepare function to send output to the console, indicating that the job is still underway while the food's being prepared. So let's give this a quick run and just kind of see what we can expect from it. So we can see that we're preparing all three, and when the eggs are done, then it's just the steak and the salad. And then when the salad's ready, then it's just the steak. So let's put a breakpoint on the printline function down here. And let's give this another run, this time in debug mode. And as expected, the execution pauses on this line with the breakpoint on it. And one neat thing about using the debugger with coroutines is that the step commands will pin to the current coroutine. So despite the fact that we've got the eggs, the salad, and the steak, they're all using this prepare function. But if we step over it here and keep stepping over, you'll see that every time we end up with a steak. And that's because the step over is going to stay on to that same coroutine that we're already on. The egg and salad coroutines are running into this breakpoint too, but because I originally hit the breakpoint for the steak, the debugger won't jump to another coroutine. However, if we were to just hit this resume program button here, then you can see the breakpoint will pause execution for other coroutines, like here we got the salad. So when using the step commands, you'll stay in the same coroutine, but when you use the resume program button, you can switch between coroutines. Next, let's take a look at the threads and variables tab, which you can find over here. And let's clear out our breakpoint that we had before. And I'm going to come up to the line where the eggs are done right here, and I'm going to set a breakpoint on that. And let's restart our debugging session. Now the IDE over here on the left helpfully shows us a stack trace that's across all the threads using this async stack trace that you can see right here. And this should be on by default, but if not, you can just right click here and make sure that you've got async stack traces turned on. And if you don't see that, make sure you update your IDE to a newer version. Now, as you expect, the top of the stack here shows where our breakpoint occurred. So if we were to click on invoke suspend, that's exactly where we set our breakpoint. The invoke suspend function is part of the internal machinery of coroutines. And so you would see it if you were to decompile the bytecode of this file into Java, for example. Now we can click on the cook eggs item right here, and that's going to take us up to the function where we called launch. We can scroll down a little bit farther on the next invoke suspend, and that takes us up to where the cook eggs function was called from. And then we can go down a little farther and we get main 7, and that's where our run blocking was called. And then of course, main -1 is just telling us that this is the entry point for our program. So even though our stack trace involved frames that were on different threads, we were able to follow the call stack all the way down to the root of the program. Now, none of this tells us about what other coroutines are running, so let's see what we can do about that. Let's come over here to the Layout Settings button, and we're going to come down here and pick Coroutines to show the Coroutines tab. Now, I'm going to slide this over so we get a little bit more room here. And we get this Coroutines hierarchy here. Let's expand that group. And we get this blocking coroutine that's from our run blocking. Let's expand that as well. And now we can see all of the coroutines that are in flight. So here we've got 2 coroutines that are suspended, and we've also got a third that's running. Now it's a little hard to tell which coroutine is which, and a good way to clarify that is to give your coroutines names. So let's do that now. I'm going to stop running our debug session. I'm going to minimize this here. And then inside each call to launch, let's add a coroutine name like this. All right, let's run this again with debug mode turned on and see what we get. We'll open up the coroutines again. And now when we look at our coroutines tab, we can see which coroutine is which. So our steak and our salad are suspended and our eggs are still running. Now we can open these to see the normal stack trace of each. So if we expand this here, for example, we get the stack trace. And the biggest reason that this stack trace is helpful is that it shows us where each coroutine is. So for example, we can open the steak coroutine stack trace here. And when we double click on prepare, you can see we are hanging out at the delay, and that's why it's suspended. Same thing should be the case for salad. If we go to prepare, that's the exact same spot. And then for eggs, we can see that we're obviously printing that the eggs are done because that's where we set the breakpoint. One last thing you can do is inspect the context of the coroutine. And the context is the object that holds the dispatcher and the name that we specified. And it also usually includes the job object that you get when you were to call launch or async, for example. Async, it would be deferred, but it's still a job object. Now, if you don't have this button right here, evaluate expression, let's go ahead and add it now. You can come over here to the 3 dots, click on add actions, and then just scroll down until you see evaluate expression. Hit that. Make sure it's selected and then hit OK, and then you'll have this button right here. Now, when you click on that button, we can evaluate an expression at the current breakpoint. So I'm going to just type coroutine context like this, and hit enter. And we get an overview of the coroutine context. You can see here with this is just the default string output. So we see we got a name, a standalone coroutine, and dispatchers.default, but we can also drill into the properties of these different elements of the coroutine object. So let's open up what we got right here, which is dispatchers default, and we can see the core pool size. We can see the scheduler name. We got a lot of other information here. And we can open up left to get the next thing in the context. Let's open up the element for that one. And we see this is a standalone coroutine, and that is the job object. And we can click on get to get these properties. And we can also drill into the context one more time. Let's open up left once more. And we get this coroutine name that we'd specified, which is steak in our case. I don't debug with this approach quite as often as the others, but occasionally it can be a big help to dig into the details of the context object. Well, that's about going to do it for this video. With these debugging tools, I hope you'll have an easier time figuring out what all of your coroutines are doing at any given moment. Thanks so much for watching, and then be on the lookout for another video on Friday when I'm going to demonstrate some common coroutine bloopers that you'll want to make sure to avoid. I'll see you then.